Good evening. So in today's video, I'm going to do something a bit different from what I used to do before. And in that, I'm going to do something I would normally do in a stream, but it's going to be something, it's going to be in the form of a video. And the reason for that is I still don't react to people on the internet very well. So if I basically I can't really do public appearances like live streams because I get stressed out or I get disappointed that too few people are watching or something along those lines. So I decided to do something I would normally do in a stream but in the form of a video. And another thing is that I'm going to be doing a reaction video, and more specifically, I'm going to be reacting to a book. And this book is pretty well known by people all around the world. It's called The C Programming Language by Kernighan and Dennis Ritchie. And another thing I noticed is that maybe I shouldn't worry too much about my accent because some YouTubers actually make their Slavic accents part of their identity. Like there is one called Radal. He grew up in Austria, so he actually should have an Austrian accent, but he makes his what would they call it? A stereotypical Serbian accent a part of his identity, and therefore I have decided to care less about the authenticity of my accent. And having said that, I'm going to start reading the book and I'm going to start implementing the examples. And this book is very old. I think this edition comes from 1988, and it's one of the first books about the C programming language, and it was originally written by the original creators of the language and the original creators of the Unix operating system. So some parts of the book may be written in an archaic way, and some parts may be not working, and it remains to be seen how well this is going to work out. And hopefully you enjoy and learn something along the way. And with that said, let me begin typing away. Okay. Yeah, I have to figure out a placement for a microphone because the previous one didn't seem to work out very well. Okay, great. The C programming language, second edition by Brian W. Kernighan and Dennis M. Ritchie. From the preface. We have tried to retain the brevity of the first edition. C is not a big language and it is not well served by a big book. We have improved the exposition of critical features such as pointers that are central to C programming. We have refined the original examples and have added new examples in several chapters. For instance, the treatment of complicated declarations is augmented by programs that convert declarations into words and vice versa. As before, all examples have been tested directly from the text, which is in machine-readable form. As we said in the preface to the first edition, C wears well as one's experience with it grows. With a decade more experience, we still feel that way. We hope that this book will help you learn C and use it well. Okay, preface to the first edition. Preface. The computing world has undergone a revolution since the publication of the C programming language in 1978. Big computers are much bigger, and personal computers have capabilities that rival the mainframes of a decade ago. During this time, C has changed too. although only modestly, and it has spread far beyond its origins as the language of the Unix operating system. The growing popularity of C, the changes in the language over the years, and the creation of compilers by groups not involved in its design combined to demonstrate a need for a more precise and more contemporary definition of the language than the first edition of this book provided. In 1983, the American National Standards Institute established a committee whose goal was to produce an unambiguous and machine-independent definition of the language C, while still retaining its spirit. The result is the ANSI standard for C. Blah blah blah. The standard formalizes constructions that were hinted at but not described in the first edition, particularly structure assignment and enumerations. Okay? The second edition of the C programming language describes C as defined by the ANSI standard. So here I should probably point out that on modern Linux operating systems, we probably have a newer C compiler available, and that is this enables us to use some new features, such as, for example, I think the Boolean type is a part of a newer C standard, and another one is C++ type comments, so the ones that start with a double slash. And in older C code, you would have to write all comments in this form with like longer form. And this is probably not the most convenient syntax, so I may end up just using the C++ type comments. And okay, we have tried to retain the brevity of the first edition. C is not a big language, and it is not well served by a big book. Great. We have improved the exposition of critical features such as pointers that are central to C programming. Yep. Appendix A, the reference manual, is not the standard, but our attempt to convey the essentials of the standard in a smaller space. It is meant for easy comprehension by programmers, but not as a definition for compiler writers. That role properly belongs to the standard itself. Appendix B is a summary of the facilities of the standard library. It too is meant for reference by programmers, not implementers. Appendix C is a concise summary of the changes from the original version. As we said in the preface to the first edition, C wears well as one experience with it grows. Yep. And afterwards is a long list of people who have contributed to the book, like they express their thanks, and this place already mentions Bjarne Straustrup's C++, and this means that this book was actually released after the C++ was first released. Our sincere thanks to all, Brian W. Kernighan and Dennis M. Ritchie. And I was actually born in 1993, which is 5 years after this edition was published. So this book is older than me. Okay. Another preface. C is a general-purpose programming language which features economy of expression, modern control flow and data structures, and a rich set of operators. C is not a very high-level language, nor a big one, and it is not specialized to any particular area of application, but its absence of restrictions and its generality make it more convenient and effective for many tasks than supposedly more powerful languages. I wonder what they meant by that, because at the time they had like basic Fortran, COBOL, and probably not much all. C was originally designed for and implemented on the Unix operating system on the DEC PDP-11 by Dennis Ritchie, one of the writers of his book. The operating system, the C compiler, and essentially all Unix applications programs including all of the software used to prepare this book, are written in C. Okay. Production compilers also exist for several other machines, including the IBM System 370, the Honeywell 6000, and the Interdata 832. C is not tied to any particular hardware or system, however, and it is easy to write programs that will run without change on any machine that supports C. Okay, so obviously all of these systems here have been obsolete for several years, but as far as I know, there were C compilers for most popular machines available in the other period following this book. So, for example, the Commodore 64, I think there was a C compiler for it, and also C was already hugely popular in the 80s. And I remember when I was growing up, I read some computer magazines from the 80s, and they already included C tutorials. Okay. This book is meant to help the reader learn how to program in C. It contains a tutorial introduction to get new users started as soon as possible, separate chapters on each major feature, and a reference manual. Most of the treatment is based on reading, writing, and revising examples rather than on mere statements of rules. Okay? The thoughtful criticisms. Okay, great. Now, an introduction. After two prefaces, we have an introduction. C is a general-purpose programming language. It has been closely associated with the Unix system where it was developed, since both the system and most of the programs that run on it are written in C. The language, however, is not tied to any one operating system or machine, and although it has been called a system programming language because it is useful for writing compilers and operating systems, it has been used equally well to write major programs in many different domains. Many of the important ideas of C stem from the language BCPL developed by Martin Richards. The influence on BCPL on C proceeded indirectly through the language B, which was written by Ken Thompson in 1970 for the first Unix system on the DEC PDP-7. Okay, I have literally no idea what the PDP-11 looked like. Okay. Yeah, so actually it's much smaller than I expected. I've always thought that mainframes were basically as big as rooms, but this already looks like a reasonable size. And to think that it already ran Unix. BCPL and B are typeless languages, and that probably means they were dynamically typed. By contrast, C provides a variety of data types. The fundamental types are characters and integers and floating point numbers of several sizes. In addition, there is a hierarchy of derived data types created with pointers, arrays, structures, and unions. Expressions are formed from operators and operands. Any expression, including an assignment or a function call, can be a statement. Pointers provide for machine-independent address arithmetic. Okay, so here they write it out as a feature, but as we know, Go was specifically designed to disallow pointer arithmetic because it was just a source of so many errors. C provides the fundamental control flow constructions required for well-structured programs. Statement grouping, decision making, selecting one of a set of possible cases, looping with termination tests at the top or at the bottom, and early loop exit. Functions may return values of basic types, structures, unions, or pointers. Any function may be called recursively. Local variables are typically automatic or created anew with each invocation. Function definitions may not be nested, but variables may be declared in a block-structured fashion. So later on, we may see that in like the early ANSI C, you actually had to define all variables used in a given function in the beginning of a function, because this was the only way you could, at the time, this was the only way you could write a single pass compiler. And I think it needed to know all the variables beforehand, so it could calculate the stack size and stack layout. Functions may return values of basic types, structures, unions, or pointers. Any function may be called recursively. Yes. A preprocessing step performs macro substitutions on program text, inclusion of other source files, and conditional compilation. C is a relatively low-level language. This characterization is not pejorative. It simply means that C deals with the same sort of objects that most computers do, namely characters, numbers, and addresses. These may be combined and moved about with the arithmetic and logical operators implemented by real machines. C provides no operations to deal directly with composite objects, such as characters, strings, sets, lists, or arrays. There are no operations that manipulate an entire array or string, although structures may be copied as a unit. The language does not define any storage allocation facility other than static definition and the stack discipline provided by the local variables or functions. There is no heap or garbage collection. Oh well, I thought the heap was malloc. Yes, so it only says it comes from the standard library. It doesn't say when it was introduced. POSIX from 2001, C99. I wonder, was malloc available in ANSI? Okay, I guess we won't easily find out. Finally, C provides no input-output facilities. There are no read or write statements and no built-in file access methods. All of these high-level mechanisms must be provided by explicitly called functions. Most C implementations have included a reasonably standard collections of such functions. Similarly, C offers only straightforward single-thread control flow, tests, loops, grouping, and subprograms, but not multiprogramming, parallel operations, synchronization, or coroutines. Yes, so this was one of the reasons why languages like Elixir, Erlang, or Golang took off, because with C, it's very difficult to write multi-threaded or multi-processor programs. As in, you need to do things like, I think it's called IIRC. Basically, it's not a great experience writing parallel programs in C. You mean I have to call a function to compare two character strings? Keeping the language down to modest size has real benefits. Since C is relatively small, it can be described in a small space and learned quickly. A programmer can reasonably expect to know and understand, and indeed regularly use, the entire language. For many years, the definition of C was the reference manual in the first edition of the C programming language. In 1983, the American National Standards Institute established a committee to provide a modern, comprehensive definition of C. The resulting definition, the ANSI standard, or ANSI-C, was completed late in 1988. Most of the features of the standard are already supported by modern compilers. The standard is based on the original reference manual. The language is relatively little changed. One of the goals of the standard was to make sure that most existing programs would remain valid, or failing that, but compilers could produce warnings of new behavior. For most programmers, the most important change is a new syntax for declaring and defining functions. A function declaration can now include a description of the arguments of the function. The definition syntax changes to match. What? I wonder what the first edition looked like. Wow. There are other small-scale language changes. Structure assignment and enumerations, which had been widely available, are now officially part of the language. Floating point computations may now be done in single precision. The properties of arithmetic, especially for unsigned types, are clarified. The preprocessor is more elaborate. Most of these changes will have only minor effects on most programmers. A second significant contribution to the standard is the definition of a library to accompany C. It specifies functions for accessing the operating system, for example, to read and write files, formatted input and output, memory allocation, string manipulation, and the like. Most of the library is closely modeled on the standard I/O library of the Unix system. This library was described in the first edition and has been widely used on other systems as well. Again, most programmers will not see much change. So actually, I have originally intended to write these programs on a real Unix, on a true Unix, because I'm currently on Debian, and Debian is based on Linux, which is not a true Unix. It's a Unix-like operating system, but not all the APIs and not all the features are exactly one-on-one compatible with Unix. But hopefully this is not going to be an issue. Because blah 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 blah. Yeah, this is alone. C, like any other language, has its blemishes. Some of the operators have the wrong precedence. Some parts of the syntax could be better. Nonetheless, C has proven to be an extremely effective and expressive language for a wide variety of programming applications. Okay. The book is organized as follows. Chapter 1 is a tutorial on the central part of C. Chapters 2 through 6 discuss various aspects of C in more detail and rather more formally than does Chapter 1. Blah blah blah. Okay, yeah, this is a long introduction. Okay, so this book, I think the Kernighan and Ritchie book was the source of the original Hello World program. So the hello world that you write in every single tutorial for every single programming language, it originally came from the Kernighan and Ritchie book, the C programming language book. And now is the time for us to implement it in C. Okay, well, fit width, okay. So, okay, I'll call the program hello. And this program should compile without any modification, but it's going to have compiler warnings. So okay. In C, the program to print hello world is blah, blah, blah. Just how to run this program depends on the system you are using. As a specific example, on the Unix operating system, you must create a program in a file whose name ends in .c, such as hello.c, then compile it with the command cc hello.c. Okay, so cc is actually the standard compiler command on all Unix systems. So although it did complain about the default type, return type defaults to int, it's because of w implicit int, but it did compile. And now if I run it, it works. So far so good. We could also explicitly set this return type, and then it doesn't complain, even though we haven't actually returned a value. Okay, if you run a.out by typing the command a.out, by the way, this wouldn't work on Linux because by default the current directory is not in the path, is not in the program search path, so it would just complain that the file does not exist. So you see, command not found. On other systems, the rules will be different. Check with a local expert. Now for some explanations about the program itself. A C program, whatever its size, consists of functions and variables. A function contains statements that specify the computing operations to be done, and variables store values used during the computation. C functions are like the subroutines and functions of Fortran, or the procedures and functions of Pascal. Okay, so this is an insight as to what the programming ecosystem looked like in 1988. We had C++, we had Pascal, we had Fortran, and obviously we already had BASIC because at that time the Commodore 64 was already a bestseller, and actually in 1988 I think the original IBM PC came out, which is okay. Our example is a function named main. Normally you are at liberty to give functions whatever names you like, but main is special. Your program begins executing at the beginning of main. This means that every program must have a main somewhere. Main will usually call other functions to help perform its job, some that you wrote and others from libraries that are provided for you. The first line of the program, #include stdio.h, tells the compiler to include information about the standard input-output library. This line appears at the beginning of many C source files. The standard library is described in Chapter 7 and Appendix B. One method of communicating data between functions is for the calling functions to provide a list of values, called arguments, to the function it calls. The parentheses after the function name surround the argument list. In this example, main is defined to be a function that expects no arguments, which is indicated by the empty list, empty parentheses. The statements of a function are enclosed in braces. The function main contains only one statement, printf hello world. A function is called by naming it, followed by a parenthesized list of arguments. This sounds very formal, but it basically says that if you want to call a function called printf, you write the name of the function, and then you add parentheses, and then inside it you write all the arguments you want to pass to a function, which is probably is like a second nature to most of the viewers, but if you didn't know it, this is what it means. Printf is a library function that prints output, in this case the string of characters between the quotes. A sequence of characters in double quotes, like hello world, is called a character string or string constant. For the moment, our only use of character strings will be as arguments for printf and other functions. The sequence \n in the string is C notation for the new line character, which when printed advances the output to the left margin on the next line. Okay, yeah. If you leave out the \n, a worthwhile experiment, you will find that there is no line advance after the output is printed. Yep. So basically we have to include this, otherwise there will be no output. And yeah, so I'm using ZSH, so it just prints a %sign after the output. But I think if we use like a regular shell, it would just print the prompt directly after the output of a program. So we need to change it back. Okay, yeah, well, yeah, okay, we still haven't recompiled it. cc hello c a.out, and now it prints a new line. Yes, great. You must include \n to include a new line character in the printf argument. If you try something like printf hello world, blah blah blah, the VC compiler will produce an error message. Okay, let's see. Yeah. Yeah. See, missing terminating double quote character. Okay, so it even tells me where the error is, and we can just restore it back to the original like this. Okay. Printf never supplies a new line automatically, so several calls may be used to build up an output line in stages. Our first program could just as well have been written printf hello, so like hello world and a new line printed in separate statements. Notice that \n represents only a single character. An escape sequence like \n provides a general and extensible mechanism for representing hard to type or invisible characters. Among the others that C provides are \t for tab, \b for backspace, \double quote for the double quote, and \/ for the / itself. There is a complete list in section 2.3. Okay. Exercise 1 of 1. Run the Hello World program on your system. Experiment with leaving out parts of the program to see what error messages you get. We have already done that. experiment to find out what happens when printf's argument string contains \c, where c is some character not listed above. Yeah, well, I'm not gonna do it. Okay, we can go to the second listing, which is a Fahrenheit to Celsius converter. So unless you are in one of the very few places that uses Fahrenheit, and that's probably most of the United States and probably the Federated States of Micronesia, or whatever it is called officially, then you will be using centigrade or Celsius, and I do it too. My brain is wired for Celsius because I grew up in Europe, and yes, the formula is you subtract 32 from the Fahrenheit number, and then you multiply it by 5 divided by 9, and then you get the Fahrenheit temperature. And actually this is doing integer arithmetic, so it's not going to be terribly precise. Okay. The next program uses the formula Celsius equals 5 divided by 9 times Fahrenheit minus 32 to print the following table of Fahrenheit temperatures and their centigrade or Celsius equivalents. Okay, yep, a list. The program itself still consists of a definition of a single function named main. It is longer than the one that printed hello world, but not complicated. It introduces several new ideas, including comments, declarations, variables, arithmetic expressions, loops, and formatted output. Yeah, sorry, that's my rice cooker. Great. Include stdio. Okay, I think it was called far.c. Okay, far.c, and I close this one. Include stdio.h and comment. Okay, yeah, print Fahrenheit Celsius table for far equals 0, 20 up until 300. And you may have noticed that my editor already gave me, it basically printed a new asterisk for me. Int main, we are just going to add the int main in here. Yeah, okay. Int Fahrenheit Celsius, int lower upper step, lower equals 0, upper equals 300, step equals 20, Fahrenheit equals lower, while Fahrenheit is less than upper, Celsius equals 5 times Fahrenheit minus 32 divided by 9, print f, %d tab, %d new line, Fahrenheit Celsius, Fahrenheit equals Fahrenheit plus step. Yes, obviously we could have written this as a for loop, but actually a for loop is just a wrapper over a while loop. Okay, the two lines, print Fahrenheit Celsius table for Fahrenheit equals 0, 20 up to 300, are a comment, which in this case explains briefly what the program does. Any characters between / asterisk and * are ignored by the compiler. They may be used freely to make a program easier to understand. Comments may appear anywhere a blank or tab or new line can. In C, all variables must be declared before they are used, usually at the beginning of a function before any executable statements. A declaration announces the properties of variables. It consists of a type name and a list of variables such as int Fahrenheit Celsius, int lower upper step. We type int means that the variables listed are integers, by contrast with float, which means floating point, i.e. numbers that may have a fractional part. The range of both int and floats depends on the machine you are using. 16-bit ints, which lie between 32,000 minus 32,768 and plus 32,767 are common, as are 32-bit integers. Yeah, I think on 64-bit machines, an integer is 32 bits long. And then you have a long integer, which will be 62 bytes long, and so in the standard library there is something called stdint, I think, and then you can just define your variables like this. But I don't think this existed when this book was first published. No, okay, man, you int 32t. Okay, yeah. So yeah, it says you int 32 width is for, yeah. You int n underscore t are assigned integers types. Okay, according to POS6, integer int 8t or yeah blah, 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 are required. You int 64t are only required in implementations that provide integer types with width 64, and all other types of this form are optional. Okay, so what do we have? Okay, so this is not here in the book, but it's a good thing to know. But in C you can also have like a proper types with defined width. Otherwise you may end up with like chars that are 2 bytes wide, which would be wild, I guess. Great. C provides several other basic data types besides int and float, including char, short, long, and double. And this is 1 byte, 2 bytes, 4 bytes, and 8. Okay, and 8 bytes, I think. But unless we are doing a single byte binary, like a binary data, there is no point in using short, because the processor is operating on 64-bit words anyway. Most registers are 64 bits, and you just end up having to align. You define something as a short, and then you may find out that it takes 8 bytes in memory anyway, because it's more efficient for a 64-bit processor. So yeah, basically most of the time we are probably just going to be defining integers as ints, whatever they are. Great. Do I have a manual entry for int? Nope. The sizes of these objects are also machine dependent. There are also arrays, structures, and unions of these basic types, pointers to them, and functions that return them, all of which we will meet in due course. Computation in the temperature conversion program begins with the assignment statements. Lower equals 0, upper equals 300, step equals 20, and Fahrenheit equals lower. which set the variables to their initial values. Individual statements are terminated by semicolons, which means that after every statement or expression, after every statement, you must use a semicolon, otherwise you get a compiler error, a syntax error. Each line of a table is computed the same way, so we use a loop that repeats once per output line. This is the purpose of the while loop. Okay, and here the condition is that we are iterating until Fahrenheit becomes at least becomes bigger, and we are doing this with a while loop, which means that while Fahrenheit is less than or equal to upper, we calculate a Fahrenheit value and we print it out and increment. Do I have Clang format? Install and Clang D, okay. Yep. Let me see. So now with now if we okay. Do I have something like? Am I going to get what? Okay. Yeah. Okay. I guess I'm just not going to use the Neo format. Because I would end up getting like 2 spaces instead of 4, which I don't particularly enjoy in C code. Okay. The body of a while can be one or more statements enclosed in braces, as in the temperature converter, or a single statement without braces, as in while I is less than j, I equals 2 times I. Okay, this is a very long explanation. I think it's pretty clear what it does. These definitions are all written in the beginning of a function, but actually in more modern versions of C you can also set the values in the definition, as I will show you soon. And I think I'm going to use makefar. So make by default just compiles the C file with CC. Okay, and did I get the same result? Yes. So we did get the same result as in the book, which means that it works. So let me show you what I meant. So lower equals 0, upper equals 300, and step equals 220. And I could just remove this part, and it still works just fine. But we cannot leave the initializer out, because then it still works in here, but it's technically undefined behavior. So it could work 99.9% of the time and not work at some point. Great. So we have done the second. We have went over the second example, and I think this is pretty clear what it does. Okay, it says great. There are a couple of problems with the temperature conversion program. The simpler one is that the output isn't very pretty because the numbers are not right justified. That's easy to fix. We augment each %d In the printf statement with a width, the numbers printed will be right justified in their fields. For instance, we might say like this. Okay, let's see. Yep, so this way we are right justified. The more serious problem is that because we have used integer arithmetic, the Celsius temperatures are not very accurate. For instance, 0 Fahrenheit is actually about minus 17.8 Celsius, not minus 17. To get more accurate answers, we should use floating point arithmetic instead of integer. This requires some changes in the program. Here is a second version. Great. Okay, so float Fahrenheit Celsius, integer lower upper step, and then we are going to display numbers like this. 3.0 F 6.1 F, what? And Celsius is, okay, why does it complain? Invalid conversion space. Okay, I see. Okay. So we converted Fahrenheit and Celsius to floats, and we kept these steps as integers because I guess it's because they take less memory, which would have been an issue in the 1980s. And here we can, they also change the formula, so we can just convert this to a, it converts the, yeah, basically we use a different formula. This is much the same as before, except that Fahrenheit and Celsius are declared to be float, and the formula for conversion is written in a more natural way. We were unable to use find 5 divided by 9 in the previous version because integer division would truncate it to 0. A decimal point in a constant indicates that it is floating point. However, so 5.0 divided by 9.0 is not truncated because it is the ratio of two floating point values. If an arithmetic operator has integer operands, an integer operation is performed. If an arithmetic operation has one floating point operand and one integer operand, however, the integer will be converted to floating point before the operation is done. Yeah, okay. Nevertheless, writing floating point, so we could also write it like this, and it should probably still work fine. Yep. Or yep. Or we could write it like this, and it still works fine. So as long as at least one of those is a float in literal, it will be divided using floating point arithmetics. Great. Notice that the assignment Fahrenheit equals lower, and while Fahrenheit is less than or equal to upper, also work in a natural way, and this means that we are assigning an integer to a float, and this is implicitly converted, which maybe is not great. It wouldn't work like this in Go. Go would just complain that Fahrenheit is a float and this is an integer, and would have you convert it. But maybe in the 1980s it was a good idea. I don't know, it's so high level it almost looks like Java. Great. Width and precision may be omitted from a specification. %6f says that the number is to be at least 6 characters wide. %.2f specifies 2 characters after the decimal point, but the width is not constrained. And %f merely says to print the number as floating point. Among others, printf also recognizes %o for octal, %x for hexadecimal, %c for character, %s for character string, and %% for percent itself. Modify the temperature exercise 1.13. Modify the temperature conversion program to print a heading above the table. Great. Printf temperature conversion table. Great. And we have to include a new line character. Okay, great. And write a program to print the corresponding Celsius to Fahrenheit table. Okay, so that's going to be a bit more tricky, but assuming that we are going to use the same range, as in 0 until 300 degrees Celsius, we can just write Celsius equals lower, while Celsius is less than or equal to uppers. Fahrenheit equals 9.0 times Fahrenheit times Celsius, like this. Times Celsius plus 32, I think. And then we get Celsius okay. Let's see, Fahrenheit, and then Celsius equals Celsius plus step. Let's see. Yeah, this looks more or less correct. We get, is it though? 20, is it though? 20 times 9 plus 30, yeah, checks out. 40 times 9 divided by 5 plus 32. Okay, yeah, I guess there is no need for, there's not really too much need for a floating point when you are converting this way. And what if we use a lower step, like 5? I guess you still don't need a, seriously though. Yeah, this is 5 degrees and then it's like 9 degrees above 32. I guess this makes sense. Great, and I see we've been, I've been recording for almost an hour. So I would like to also announce that I may make more videos like this. And I don't know, it feels a bit low effort, but actually making a real tutorial video is really like 100 hours of work, and then maybe 100 people will watch it. And I guess I would like to interact more with my subscribers. And I know some people have made requests in the comments, like somebody has been asking for a Swagger tutorial. I have never used Swagger, so, and yeah, I've never used Swagger, and I've never really been a great fan of those API tools, and I don't know, maybe it's good, maybe it's not. It's also, I've recently been interested a lot in what's it called, in cryptography, and so yeah, I've been interested in cryptographies, and I've been thinking of what's it called. I've been thinking of making a tutorial about how to write a secure cookie library from scratch in Go, and that's going to be using a lot of new interesting cryptographic principles and concepts. And I've been just working on the script for like 2 weeks and still haven't even finished a blog post that would back this video. So maybe I'll just make a video without too much preparation, and if it's too bad, I'll just redo it. And I probably wouldn't like to do it because my inner perfectionist is going to be very unhappy, but you know, if I have to do it, I'll do it. And if all that said, I think I'll just stop recording and upload, and I'll see you in the next video. Bye.